Bismillah ar-Rahman ar-Rahim. Today, inshallah, I'm going to explain about the transformer vector group testing. The previous video, we explained about the vector group, especially about the most famous vector group in our electricity network, that Dyn11. We say that the Dyn11 means the primary side of the transformer we connected delta connection, Y the secondary side we connected star connection, and means neutral. 11 means the secondary side lead the primary side with the phase shift 30 degree, and we say that how the 30 degree it came. Okay, now let's see how we test the transformer vector group, because very important to check that the transformer has the right vector group. Okay, because in the nameplate, if you mention the vector group Dyn11, we need to check that it is exactly it is Dyn11, because as you said before, if you need to run two power transform in parallel, and if one of this power transform has different vector group, the synchronize between this transform will not happen. Okay. Now let's see how we'll test this vector group Dyn11. Now let's draw the transformer example now. Now I assume I have this transformer. This is the delta connection. This R capital, Y capital, P capital, and here this secondary side. Okay, this R small, Y small, B small, and neutral. This is the transformer. Okay. Okay. So the first things we need to do when we test power transformer here, this Dyn11, the first thing we need to do, we'll make jumper between R capital and R small, like this one. So first things we need to make short between R capital and R small. Then I will bring 450 volt AC source. Okay, I will inject 3-phase AC source 450 at the primary side, like this one. So this is the connection what we have. This is the connection what I need to test the power transformer. Okay, or to test the vector group of the transformer. Now, if when you connect all this connection and inject 450 volt AC source, here I need to measure all the reading, the voltage reading between all the phases. R to Y, like example, I need to measure RY capital, okay, RY capital, YB capital, RB capital, R capital, R small, R capital Y small, R capital B small, R neutral. Again for all the phases. Then again Y to R small, example here, Y capital R small, Y capital Y small, Y capital B small, Y neutral. All the reading should be taken. Okay, for the test test report format. Okay, we need to measure all the reading in the test report. When you measure all the reading, just mention the reading here. Okay, now I want to check that my reading here it's okay. Okay, and now I take the reading, but how I will know that this reading is okay or not? How I check that one? So to ensure the reading is okay, first things I will draw here this the delta connection as we explained in the previous video. This R capital, this Y capital, and this B capital. Okay. Now what's first thing we did here? We make short between R capital and R small. So this is the delta connection. Now I want to draw the star connection here. So the star connection will be like this one. This R small, this Y small, and this B small, and this one here the neutral. Okay, so we'll come like this one. So if you see the distance between R capital and R small, it's almost zero, right? If you check between R capital and R small here, this one, the distance almost zero. So the measuring voltage here should be around zero. So when you take the reading between R capital and R small, the value here should be zero. This is the first reading we need to take it. Okay? Now I will do another assumption. You must do another assumption. At least we need to do 5 to 6 assumption. Now, if you check the distance between R capital, B capital, this one, R and B capital, this here, I will say it will be equal R capital, Y capital. See the distance here, right? So example, if RY here give me 450, the RY capital, RY capital and RB capital should be here also 450 volt. So here will be 450 volt and 450 volt. This is another assumption. So let's do another assumption again. Last example we say R capital, B small, okay, R capital this one and B small this one, okay, will be equal R capital, Y small. Now example, if RB small here give me 50 volt, example, I will say example 50 volt, this will be RY small here will be over 50 volt. This I got it from where? From the test report. You need to check it from test report. I will do another assumption. Again, if you say example R capital, B small will be less than, okay, R capital, P capital. Then here from test report example, you will say here this 450 volt example, and this you find example I will say 50 volt. We'll find it less than RB capital. Then we'll do another assumption. You can do a lot of assumption. Then we need to check it from the test report, result of the test report. This how we will test the transformer vector group of the transformer, and this how we check that the vector group it is Dyn11. Because if you the vector group if you have a 2 power transformer and the result of this 2 power transformer is different, that means one of this power transformer has different vector group. Sometimes even if the nameplate is mentioned vector group Dyn11, but in reality it is not Dyn11. Maybe some manufacturing error. Okay, so this is how we check the transformer vector group of the transformer before commissioning or energize the power transformer. Okay, so I hope the vector group of the transformer and the transformer testing it is clear.